is projection of lines. We know that line, so the locus of a point which moves unidirectionally is known as a straight line, or we can call it as the shortest distance between the 2 points. The shortest distance between the 2 points is also we can call it as a straight line. So the straight line having only one dimension, so it has only a unidirectional, that means it has only one dimension. So the actual length of the line is, we can call it as the true length of the line. It is denoted with TL, and the reduced length of the line is, we can call it as the projected length, or we can call it the apparent length. It is smaller than the true length. It is the smaller than the true length, and it is denoted with PL. So coming to the positions of a straight line, I am explaining one by one here. Positions of a straight line. So line parallel to both HP and VP, line parallel to VP and perpendicular to HP. These positions are very, very important. So from the positions of the line, they are asking different problems. Line parallel to HP and perpendicular to VP, line parallel to VP and inclined to HP, and another position is line parallel to HP and inclined to VP, line is on HP and inclined to VP, line is on VP and inclined to HP, and last one is line inclined to both HP and VP. So here in this condition, so in this position we have two cases is there. If theta plus phi, that means angle with respect to HP and angle with respect to VP sum is less than 90 degrees, we have solving the problems by using the change of position, by using the rotating line method. And if theta plus phi is 90 degrees, if the projector is on the same projector line, so how we will draw the line problem whenever the projector is on the same projector line? So theta plus phi is equal to 90 degrees. So in that case, how we will draw the projections of a line? So we can study one by one. So here, so coming to the first, so here conventions of a straight line. That means, so in this topic, what are the thick lines and what are the thin lines? So coming to the thin lines, that should be drawn by using a 2H pencil. So XY line, projection line and construction lines and dimension line should be drawn by using a 2H pencil. And coming to the thick lines are always you can drawn by using your HB pencil. So lettering and front view and top view and side views are drawn by using your HB pencil. So line parallel to both HP and VP. Suppose if I am treating, this one is, we can treat it as a horizontal plane, and I am treating this one is, so my hand, so this one is treating as a vertical plane. Suppose I am treating, so this book, so I am placing this one is look like, so this one is treating as a vertical plane and this one is treating as a horizontal plane. So line parallel to, I am choosing, so this is a line. So line parallel to both HP and VP means, so this is the position of the object. When a line parallel to both HP and VP, both the front view, so the direction of the front view is, we can see in this direction. So this is the direction of the front view, and the top view direction is this one. So whenever an observer see the object from the top view direction, the image of the object will get on the horizontal plane, and whenever an observer see the object from the front view direction, the image of the object will get on the vertical plane. So that here both the front view and the top views will be true length of the line. And suppose if you see the object from the side view direction, so side view direction, so we'll get a point, either you can see this point or you can see this point. So we'll draw the side view as a point whenever a line is parallel to both HP and VP. So here front view and top view shows the true length of the line and side view is a point. So now we will draw the projections of that line. So they are giving that here a 50 mm long line PQ is parallel to both HP and VP. It is 25 mm in front of the VP and 60 mm above the HP. So first of all I am drawing the reference line, and after that I am constructing the projections of point A. Point A is, it is 25 mm in front of the VP. It means here the line. So the line is 25 mm in front of the VP and 60 mm above HP. So above HP you can take 60 mm and 20 mm, 25 mm in front we can take 25 mm in front, and we will draw the end projector of that line. So line PQ. So I am representing here P dash and here I am representing P. They are giving that the true length of the line is 50 mm here. So we will draw the front view. So the front view is, and the top view should be having the true length which is drawn parallel to the reference line. So take 50 mm, we will draw a line. Similarly here also from point P also we will draw a line. And here you can locating P dash and Q dash, and here the top view of the line is PQ. So after that you can joining Q dash and Q point also. So here P dash and Q dash is our front view and PQ is our top view line. And after, for drawing the side view, so take some distance from the projection of front view and top view, draw the another reference line x1 y1, locating the intersecting point of the reference line and the x1 y1 line, and draw the meter line with an angle of 45 degrees. After drawing the meter line, from the projection of top view, just we will draw a horizontal line and we will get an intersecting point. From the intersecting point we will draw a vertical line, and similarly from the front view projection we will draw the horizontal projection line and we will get the intersecting point. So this point is, we can call it as P double dash comma Q double dash. So this is our side view. So the side view is here a point. So here I am representing the Q is in brackets because whenever you can see the object from the side view direction, P is visible and Q point is not visible, so that the invisible point is, you can locate it in brackets. So this is our left side view. So we will draw the right side view also. For drawing the right side view, we will draw the another reference line at the left side of the front view and we will construct the right side view. So I am representing only the left side view here. So after drawing the side view, we will draw the dimensions which are giving in our problem. So this is our solution, problem solution. So whenever the line is parallel to both HP and VP, both the front view and top view is having the true length, these lines are, we will get above the we will get which is parallel to the reference line with the length of true length. Both the lines are obtained as a parallel to the reference lines. So this dimension is, they are giving that 60 mm above and 25 mm in front, and also they are giving the true length of the line also, you can represent it in the diagram. So the true length of the line is, they are giving that 50. So this is the first position of a straight line. Line perpendicular to HP and parallel to VP. So here in this position also I am treating this one is the horizontal plane or the ground. So this ground is, you can treat it as the horizontal plane. I am treating this one is the vertical plane. So line, so I am treating this is the line perpendicular to HP, that means line perpendicular to the ground. So this is the position. So whenever a line perpendicular to HP, so it is always parallel to the VP. So whenever a line is perpendicular to HP, so the front view, so this is the direction of the front view is this and direction of the top view is this. So whenever you can see the object from the front view, so the true length of the line is, we will obtain on the vertical plane as a perpendicular line, as a vertical line. And if you see the object from the top view direction, so this point is visible and this point is not visible. So the top view is obtained as a point on the horizontal plane, and if you see the object from the side view direction, we will get a line, so which is perpendicular to the reference line. Okay, this is about the line perpendicular to HP and parallel to the VP. Now we will draw the projections of this one. So a 60 mm long line PQ has its end P is 20 mm above HP, and the line is perpendicular to the HP and 40 mm in front of the VP. So first of all, we will draw the projection of point P here. So draw the reference line, XY line. P is 20 mm above HP. Take 20 mm above the reference line, and 40 mm in front of the VP. You can take 40 mm in front. So where we will get the true length of the line? 60 mm. We will get the true length of the line whenever line is perpendicular to HP. We will get the true length of the line on the vertical plane. So we will draw the true length of the line perpendicular to the reference line. So here I am locating point P dash, and here, so from point P dash, so we will draw a 60 mm long line. 60 mm long line. So here I am locating Q dash. So this is the direction of the top view. So whenever you can see the object from the top view direction, point Q is visible and point P dash is not visible. So here, so Q is visible, so within the bracket, and P is not visible in the bracket, we will get the point P. So like that we will draw the front view and the top view in this problem. So the front view is look like a vertical line, and the top view is a point in the when a line is perpendicular to HP and parallel to VP. After drawing this one, we will draw the projections, and after that we will draw the side view also. Draw the projections one by one here. I am representing the projections here. So this is 60, 20 mm above HP and 40 mm in front of the VP. So here we will draw the side view also. For drawing the side view, we will draw the another reference line x1 y1, which is perpendicular to the reference line, and locating the intersecting point. From the intersecting point, we will draw the meter line with an angle of 45. After that, from the top view, we will draw the horizontal projection line. So always we will draw the projection lines by using your 2H pencil. So from this intersecting point on the meter line, we will draw a vertical projection line. From the points on the front, we will draw the horizontal projection line. From point P dash and also from point Q dash, we will draw the horizontal projection line and locate Q dash, and here you can locate P double dash. So make it thick because it is a side view. So this is our required side view. So like that we will draw the problem. So whenever a line perpendicular to HP and parallel to VP, the front view will be the true length, which is lying perpendicular to the reference line, and the top view shows as a point, and the side view is also a line perpendicular to the reference line. Line perpendicular to VP and parallel to the HP. So when a line perpendicular to the VP and parallel to the HP, so we can see the position. So I am taking this is the ground, I am taking this one is the horizontal plane, I am taking this one is the vertical plane. line perpendicular to VP means, so this is the direction of the line. Line perpendicular to this vertical plane. So this is the direction. So in this direction, whenever you can see the object from the top view, so we'll get the image of this object is we'll get on the horizontal plane. How it will look like with respect to reference line? Perpendicular to the reference line. And whenever you can see the object from the front view direction, we will get a point. So this point is visible and this point is not visible. So we will get a point on the vertical plane. And whenever you can see the object from the side view, we will get a line parallel to the XY line. So this is the direction of the side views. So we can see the object from the side. From one side we will see the object, we will get a line. So I am drawing the projection here. How we will get the projections in this position? So they are giving that a 70 mm long line AB has its end A is 20 mm in front of the VP. The line is perpendicular to the VP and 45 mm above the HP. So first of all we will draw the reference line. After drawing the reference line, draw the projection of point A. They are giving the true length of the line is 70. Projection of point A is 20 mm in front of the VP and 45 mm above HP. Take 45 mm above, 45 mm above and 25 mm in front, 20 mm in front. So where we will get the true length? So below the reference line. So the top view is a line perpendicular to the reference line. So draw the top view with the length of 70. So here you will get point A, here you will get point B. So here you will get, so this is the direction of the top view from the bottom. So from the bottom, whenever you can see the object from the bottom, so point B is visible, point A is not visible. Visible point within the brackets and invisible point is located in brackets like that. So here the front view is shows as a point and the top view shows as a true length which is perpendicular to the reference line. So after drawing this one, we will draw the side view also. For drawing the side view, we will draw the another reference line by taking some distance. Take 10 to 15 mm distance and we will draw the another reference line x1, y1 and we will draw the meter line with an angle of 45. Now from the points on the front view, from the points on the top, you will draw the horizontal projection line. Draw the horizontal projection lines. We will get the intersecting points on the meter line. Now from the meter line, we will draw the vertical projection line. Similarly, from the projection of the front view, we will draw the horizontal projection. We'll get the two intersecting point. I am taking this one as A double dash and this is B double dash. Make it thick. So this is the side view of our problem. So after that, so you can erase the extension lines from your diagram. So this is the construction of our problem. This angle is 45 and this is the side view A double dash and B double dash. B dash and A dash is our front view and AB is our top view. Now we will give the dimensions. Dimensions to this problem. We will give the dimensions. So this dimension is they are giving that 45 mm above HP and 20 mm in front of the VP and the length of the True length of the line is 70 mm. So by observing the position, so we will draw the projections. Line inclined to HP and parallel to the VP. Line inclined to the HP and parallel to the VP. I am taking this ground is I am taking as the horizontal plane. I am taking this one is the vertical plane. So line inclined to the HP. I am taking this is the line. So line is inclined to the horizontal plane. So this is the position. So whenever a line is inclined to HP, so it is always parallel to the vertical plane. So here when a line is parallel to VP, parallel to HP, parallel to VP and inclined to HP, so it's front view. So if you see the object from the front view direction, so we'll get the front view as an inclined line with respect to. So we'll get the front view. So the front view is the true length of the line which is inclined with respect to the XY, and the top view. Whenever you can see the object from the top view, so the top view is also a line, but that line is not equal to the true length of the line. So it is a projected line. Projected line. That means it is having reduced length of line. Okay, so this is our problem. So in this direction, whenever you can see the object from the side view, also will get a line. So we'll draw that projection also. So first of all, we can give a problem. So they are giving a problem. A 80 mm long line RS has an end. R is 25 mm above HP and 50 mm in front of the VP. The line is inclined at 30 degrees to the HP and parallel to the VP. Draw the projections of the line. So first of all, we will draw the reference line XY and draw the projections of end projectors. So R is 25 mm above HP and 50 mm in front of the VP. So take 25 mm above the reference line and 50 mm in front of the VP means in front. So below the reference line you can take 50. So we will draw the end projector of point R. So here you will get R dash and here you will get small r. So the point R, top view is R dash, front view is R dash and top view is R. So after drawing the projection of point R, they are giving that inclination with respect to HP. So that means from the R dash making an angle of 30 degrees, I will draw the true length of the line from R dash making an angle of 30 degrees. I will draw the true length. What is the true length of the line? Here they are giving that 80 mm. So they are giving that true length of the line is 80. So true length of the line is 80. R dash and S dash line. And also I am representing this angle also. So from the S dash, suppose if you draw a projection line and from R we will draw a horizontal line, we will get a line which is less than the true length, which is parallel to the XY, but it is a projected length. This line length is true length, that means 80, but if you measure this line length RS, so we will get less than 80 mm. So observe this one by measuring the length. So we will obtain 68 mm, but the length of R dash and S dash is 80, and we will obtain the RS, that means the top view length is less than 80 mm. So this is our required problem. So after drawing this problem, so we will mention here the theta is equal to 30 degrees. And also mention the dimensions. So this is our R dash and S dash is our front view and RS is our top view. They are giving the dimensions of R 25 mm above HP and 50 mm in front of the VP. And also the true length of the line is also they are giving that. We can draw in an inclined manner. This dimension is they are giving that 80. So like that we will solve the problem. So this is the line inclined to HP and parallel to the VP. In this condition, the front view shows the true length which is inclined with respect to the reference line, and the top view is a line, straight line, which is parallel to XY but it is having a reduced length. Line inclined to the VP and parallel to the HP. So this is also a very important position. Whenever a line is inclined to HP and parallel to the VP, just we can observe the position. So this is the horizontal plane and this is the vertical plane. So whenever line is inclined with respect to the vertical plane, so this is the position. Line inclined with respect to the vertical plane, this is the position. So in this position, whenever you can see the object from the top view direction, we will get the true length of the line. True length of the line which is inclined with respect to the XY line. And whenever you can see the object from the front view, so we will get a straight line which is parallel to XY but it is having less than the true length of the line. So we will get a projected length as the front view. Now we will draw the projections of this line. So they are giving that here an 80 mm long line CD is inclined 45 degrees to the VP and parallel to the HP. The end C is 30 mm above HP and 40 mm in front of the VP. So first of all we will give the preference to the point projection here. Draw the end projection of point C first of all and draw your problem. So I am drawing the reference line first of all and draw the projection of point C. Point C is in the first quadrant. C is 30 mm above and 40 mm in front of the VP. 30 mm above and 40 mm in front. So 30 mm above means, so we'll get the point C, front view is C dash and top view is C. Now from point C, what is the inclination is 45 degrees. So from point C, making an angle of 45 degrees, we will draw the true length of the line. An angle is 45 and draw the true length with 80 mm. So this shows CD is our true length of the line. Now after drawing the CD with an angle of 45, I will draw from point C, we will draw a projector line, and from point C dash we will draw a horizontal line and we will get the front view. So the front view is a straight line which is parallel to the reference line, but this length is less than the true length. That means, so this length having the apparent length or reduced length. So this is the projection. So this angle is, they are clearly giving that in our problem. So this is 45 degrees. Now we will give the dimensioning. And also this dimension also we can mention in inclined manner. True length of the line CD. We will give the dimensions. Point C is 30 mm above HP and 40 mm in front of the VP. So this true length is 80. So when a line is inclined to VP and parallel to HP, so the top view shows the true length of the line which is inclined with respect to the reference line, and the front view shows as a reduced length in this position. So we'll draw the projections like that. So if you measure the length of C dash and D dash, we will get produced length, line length. So we will get approximately it should be 63 or 64 mm. So line situated on HP and inclined to the VP. So if a line is situated on the HP means on the reference line, and inclined to the VP. So how we will draw the projection? So suppose whenever a line is situated on the HP means on the reference line and with respect to the VP, inclination with respect to the VP. So in this condition or in this position, when a line is situated on the HP and inclined to VP, the top view will be the true length, because whenever you can see the object from the top view direction, we will get the true length of the line with respect to the reference line, and the front view is we will get the projected length. So it should be on the reference line we will get the front view, because the line is situated on the HP, we will get the one of the projection is on the reference line. That projection is, we can call it as the front view in this case. So first I am drawing the problem here. So they are giving that a 70 mm long line AB lying on HP and it is inclined 40 degrees to the VP. Its end A is 25 mm in front of the VP. Draw the projections of the line. So they are giving that, so I am drawing the end projector of point A here. So I am drawing a reference line XY. After drawing the reference line, so end projector is 25 mm in front of the VP and on the HP. On the HP and 25 mm in front of the VP. So end projector of point A. So A dash, so here we will get point A. So angle with respect to VP is, they are giving that 40 degrees. So with respect to the, from point A with an angle of 40 degrees, we will draw the true length of the line. The true length of the line is here 70 mm. So by making an angle of 40 degrees, we will draw the true length of the line 70. In this manner, and we will locate point B here, and from point we will draw a vertical projection line up to the reference line and locate point B dash here, and joining A dash and B dash. So this is our front view. So the front view is here, project a reduced length line which is obtained on the reference line. The top view is a true length of the line which is inclined with respect to the reference line by making an angle of 40 degrees. Now we will give the dimensions. Give the dimensions of this problem. So this is, they are giving the 25 mm in front, so the length, the true length of the line is 70. So like that we will draw the projections of a line when a line is situated on the HP and inclined to the VP. So line situated on the HP, on the VP here, the condition. Situated on VP, so that means on VP, so situated and inclined with respect to the HP. Inclination with respect to the HP, so we will get, so here in this position, so the front view will be the true length of the line which makes an angle with respect to the reference line, and the top view is here a projected length lying on the reference line. So draw the projections. So here they are giving a problem. Draw the projections of a line PQ, 70 mm long line situated on VP and inclined at an angle of 40 degrees to the HP. The end P is 30 mm above the HP. So first of all I am drawing the reference line XY. After drawing the reference line, we will draw the end projector. So end is situated in VP and 30 mm above HP. In VP and 30 mm above HP. Take 30 mm from the reference line. Locate point P here. So here we will get point P dash P, and here we will get point P dash. Now by making an angle of 30 degrees, we will draw the true length of the line. By making an angle of 30 degrees from P dash, we will draw the true length of the line. with an angle of 70. With an angle of 30 degrees, so we will draw the true length of the line. So this is P dash and Q dash. From P dash and Q dash, we will draw a vertical projection line up to the reference line and we will get the top view. So top view line, so the top view is a straight line which is parallel to the reference line, which is on the reference line. So PQ is here a straight line having a projected length. Now we will give the dimensions. So this dimension is 70 and this dimension is they are clearly giving that 30 mm above HP, and this angle is also they are clearly giving that 30 degrees. So this is the, when a line is situated in VP and inclined to HP, we will draw the projections like VP. Whenever a line is situated on both HP and VP means, so whenever a line is situated on the reference line, so the both the projections, that means the front view and top view is we will obtain on the reference line. So for drawing the projections in this case, so they are giving a problem, draw the projections of a line 75 mm, they are giving the true length of the line is 75, which is situated on both HP and VP. So we will draw the projections. So first of all we will draw the reference line and draw the projections. So here the position is, the line is situated on both HP and VP, so that we will draw the true length of the line on the reference line with the length of 75 mm. And draw the both the front view and the top view on the, so EF, so we'll get E dash and F dash on the reference line, and also EF is also on the reference line. So we'll locate the both front view and top views on the reference line in this position. So this is the, when a line is situated on both HP and VP, we will draw the projections like that. Both the projections, front view and top view, will lying on the reference line. So this one is 75. So these are the some of the important positions whenever, so in the projections of line. So in next class I am going to discuss about lines inclined to both planes.